Hi, so this is a video of the homework 1 solutions. So the first question is determine all r for which y equals e to the rx as a solution of this differential equation. Okay, so first of all, let's start with y equals e to the rx. Take the derivative once, and we get r times e to the rx. And then a second time gives us r squared e to the rx. And when we plug that into this differential equation, we're going to get 2 times r squared e to the rx is equal to r e to the rx plus 10 times e to the rx. And then I can divide both sides by e to the rx, and that will cancel those e to the rx terms. And that leaves me with 2r squared minus r minus 10 equals 0. Okay, so let's factor that. Okay, so we need to find two numbers here which will multiply to be 10, so like 2 and 5. I don't know which way they go. And then they have to add to minus 1, but there's this factor of 2 there. Okay, so let's see. Okay, so a good way to do this is I know that there's going to be this number here, it's going to be either plus or minus 2, or it's going to be plus or minus 5. So let me just plug that into this original equation here and see which one will give me 0. So let's try that. Let's do 2 times 2 squared minus 2 minus 10. And what does that give me? So that'll be 8 minus 2 is 6, and then minus 10. Okay, so that's not 0. So let's try doing minus 2. So minus 2 squared, and then minus 2 minus 10. So now I'm going to get 8 plus 2 is 10 minus 10 is 0. Okay, so I will have a plus 2 here, and that means that this is a minus 5. And let's just make sure that that's correct. So if I multiply this out, I'll get 2r squared minus 5r, and then plus 4r, and then minus 10. Yeah, so that is correct. Okay, so therefore the roots are equal to minus 2. Well, let me do it in the same order, I guess. So it's going to be 5 over 2 and minus 2. And that is our final answer. Okay, next question, number 2. We want to match the solutions y of x to the differential equation that they satisfy. So we'll start with the first one here, and we'll just grab that. So all these differential equations involve the second derivative. So we'll have to take the derivative of this twice. So we will have y prime is equal to 1 over 6 times 1 minus x times the derivative of cosine x, cosine 3x, which will be minus sine 3x, and then times 3. And then we will, we're doing a product rule, so it's plus, so the derivative of the first one is going to be a negative 1, so it's -1/6 times cosine 3x. Okay, so there's the first derivative, and let's simplify that a bit. We will get 1/2 x minus 1 sine 3x minus 1/6 cosine 3x. Okay, so that's the first derivative, and now we'll do the second derivative. So this will be 1/2 x minus 1 times the derivative of sine 3x. It's cosine 3x times 3, and then plus 1/2 times sine 3x. And then finally, we have minus, or it will be plus actually, 1/6 sine 3x times 3. So that times 3 will make this a 2. Okay. All right, let's see, does this simplify at all? It does simplify. So this will be 1/2 x minus 1 cosine 3x. Oh, it's actually, there's another 3 there, so it's 3/2. And then plus sine 3x. Okay, so let's just highlight what we need here. So we've got the original function, we have its derivative, and then we have its second derivative. All right, so what are the possible differential equations we have? Well, let's see, probably I'm looking at maybe this one here, because there's a sine 3x there, and maybe maybe that's what we'll have, because we have a whole bunch of cos 3x, sine 3x. So let's try that one. So that will be y double prime plus 9y. So let's see what we get when we plug that in and see if we'll get sine 3x. So y double prime is this. And then we'll do plus 9 times 1/6, 1 minus x times cosine 3x. Okay. So that's going to be, let's see, that 9/6 becomes 3/2, and then this is the negative of that. And so I can see that these guys cancel. Yeah, and so we're going to get just sine 3x. Okay, so that's the first one. So that means that the answer to number 1 is going to be C. Okay, so that crosses this one off the list. So that one's done. And let's move on to the next one. So now we have number 2. All right, we'll take the derivative of this twice. So we have -3 sine x, -3 cosine x, and then plus 1/2 x cosine x plus 1/2 sine x. Okay. And that does simplify a little bit. So let's simplify it. So I have -3 plus a half. So that'll be -6/2 plus a half. So it's -5/2 sine x Okay, second derivative. So that'll be a minus. And then we'll get plus 1/2 cosine x. Okay, and that also simplifies. So that'll be -4/2, better known as -2. So -2 cosine x plus 3 sine x, and then minus 1/2 x sine x. All right, so let's highlight the good stuff here. Actually, I think we probably don't need y prime. I think we just need the second derivative. So we have some like cosines and sines here, and there's this x sine x. Let's see if we can spot the differential equation. It's going to be either b or d. So one is going to be y double prime minus y, and the other is going to be y double prime plus y. So I guess let's just start with y double prime minus y and see what we get. And if it doesn't work out, then we'll do the other one. So y double prime minus y and then minus that thing. Okay, and if it turns out that we need to do plus instead, I think I can go back easily and fix that. Okay, so let's just kind of look at this, what we've got here. We have a 3 sine x, and then this will be a plus 3 sine x, so that will give me 6 sine x. And also here, these guys are not canceling either. I guess I shouldn't draw it that way, but this guy and this guy are going to add together. We get minus, yeah, so that's not going to work out. So let's go ahead and do plus then. So let's plus. So plus, now I think things are things are canceling out now. So that cancels that, and that cancels that, and then we're just going to be left with 1 cos. So it'll be cosine x. So let's see, is that what we have there? Yeah, that is it. Okay, so that one is D. And we'll cross that one off. Maybe I won't cross off the whole equation. I'll just cross off the... Okay, perfect. All right, next one. Number 3. Y prime and y double prime. Okay. Yeah, I think this one is going to be the other one. Let's try that. So we have this formula, and then we're going to do minus this formula. And what do we get? So those cancel, and these ones will 1/2 sine plus 1/2 sine. So we'll get sine x. All right, so is that what we had up here? Let's see. Yep, there it is. So that's B. So that one's B. So we're done. And then I guess we know the last one is going to be A, but I suppose we should actually verify that. So let's go ahead and just check to make sure we didn't make any mistakes. Oops, I didn't want to cut. Let's copy, move down here. Okay. And what is the differential equation? It is this guy. All right, let's copy that down here. Sort of running out of room. Put that there. So, so we want it to be that. And let me just erase this for now. So we want to get cosine 2x. So this should be equal to cosine 2x. So let's put that in. All right, let's see. So that'll cancel that. Minus 12 plus 12, so those cancel. And then we're left with 1/2 cosine x plus 1/2 cosine x. So that'll be equal to, or sorry, cosine 2x. Cosine 2x. Okay, so that's it. So that is what we wanted to see. So let's go up here. So that's definitely the right one. And we're done. Okay, last question. So now we are going to solve this. I think it was a motorboat problem. Let's see, I have it right here. Velocity of a motorboat V coasting in water satisfies this differential equation. And the initial speed of the motorboat is 10 meters per second. And V is decreasing at the rate of 1 meter per second squared when the velocity is 10 meters per second. Okay, and the question is, how long does it take for the velocity of the boat to decrease to 1/5 meter per second, so 1 meter per 5 seconds? Okay, so the trick to doing this question was to realize that in section 1.1, exercise number 43, it states that the, or it has you show that the solution of, and in that question, it's dx dt equals kx squared. So dx dt equals kx squared is x of t equal to 1 divided by c minus kt. Okay, so that was how we know what the solution of this differential equation is. So now we can use that. So we know that v of t is going to be of this form, 1 over c minus kt. Okay, and let's use our initial condition. So v of 0 equals 10. So that means that 1 over c is equal to 10. And so therefore c is equal to 1 over 10. Okay, so we have that. Okay, so that means that v of t is going to, so if I put 1 over 10 down there, I'll just multiply top and bottom of this by 10. That might make things a little bit easier. So 10 kt there. All right, so the other piece of information, so we don't know what k is yet, so we need to figure out this other piece of information. It says v is decreasing at 1 meter per second squared when the velocity is 10. And actually we could use the differential equation directly to figure out what k is from that information. So v is decreasing. That means that this is decreasing at 1 meter per second squared. So that means the acceleration is -1 meters per second squared because it's decreasing. And we also know that v is equal to 10 at that moment, right? 10, yes. And so let's just plug that into our differential equation. So we have -1 is equal to k times v squared. So that means that k is going to be -1 over 100. Okay, let's plug that into our differential, into our solution here. So -1 over 100. Okay, well, I'll just plug it in and then we'll clean this up a little bit more. So that'll end up being plus 1 over 10 times t. So I'll just multiply top and bottom by 10. So that'll give me 100 over 10 plus t. So there's our solution to this, the velocity of the motorboat. And we want to figure out when is it equal to 1/5. So that will give us 100 over 10 plus t equals 1/5. So that's 500 is equal to 10 plus t. And so therefore t is equal to 490 seconds. And that is one of the answers. Perfect. And we're done.